If you have ever wanted to build your own all-in-one sensor board, one that can track position, motion, direction, and altitude, this is it. I designed and built a prototype packed with a GPS using a ceramic antenna, an MPU6050 for motion, a ZY207 magnetometer for orientation, and a BMP280 for pressure and altitude. Today, I'll show you how I built it, how it works, and how you can make one too. So, I wanted a single compact board that can sense everything my robotic projects might need, from navigation to stability. Instead of wiring multiple modules separately each time, I decided to build a single prototype board that combines them all neatly and communicates through an ESP32-C3 Supermini. It's small, fast, and perfectly for experiments. So let's go over each of the sensors. First, the GPS module. It's got a ceramic antenna for better satellite signal strength and accuracy. That's what gives it precise coordinates, speed, and time data. Next, the MPU6050. This little chip combines an accelerometer, a gyroscope, so it knows every tilt, turn, and movement. Then we got the ZY207 magnetometer, which works like a digital compass, helping the board know its orientation relative to the magnetic north. And finally, the BMP280, which measures air pressure and temperature, from which I can calculate the altitude. All sensors connect via I2C, which means only two main wires for data, SDA and SCL. That keeps things clean and easy. Power and ground go to the 3.3 volt and ground pins on the ESP32-C3. I tried to keep the wiring short to reduce noise and interference, especially for the magnetometer and MPU6050, since both can get noisy with long cables. After wiring everything, I tested each sensor separately using Arduino IDE, just to make sure they're all responding correctly before combing them all in one sketch. The ESP32-C3 runs a simple program that reads all the sensor and prints the data to the serial monitor. The GPS gives me latitude, longitude, and speed. The MPU6050 gives me acceleration and rotation. The magnetometer gives heading, and the BMP280 reports temperature and altitude. When you combine all that, you basically get a full navigation and motion system, perfect for robots, drones, or especially my robotic car. I tested the setup by moving it around and checking how fast the data updates. The GPS locks on quickly outdoors, the MPU6050 reacts instantly to motion, and the magnetometer smoothly tracks direction. Even small changes in pressure can make the BMP280's altitude reading shift. This board is just the prototype. I'm planning to make a cleaner version on a custom PCB and maybe add a wireless data logging or a small OLED display for live readings. If you're into robotics, drones, or just love building cool tech, hit subscribe because this is only the beginning. Next up, I'll show you how I integrate this board into my robotic car. But for now, goodbye.